In this video, we'll be looking at the relationship or correlation between two variables. You've probably heard the term correlation used in everyday conversation to describe two things that are related to one another. Its use in everyday conversation is often a little vague, but we can quantify the relationship between two things using the correlation coefficient R. One of the ways to visualize the correlation coefficient is a scatter plot. Let's look at an example. In this scatter plot, the midterm and final exam scores for a biology course are plotted for each student. So the x, or horizontal axis value, is the midterm score, and the y, or vertical axis value, is the final exam score. As you might imagine, students who do well on the midterm often do well on the final. This is what we call a positive correlation. In general, students with higher midterm scores have higher final exam scores, and students with lower midterm scores have lower final exam scores. This isn't a perfect relationship, however. Some students did well on the midterm, but not as well on the final, and some did well on the final, but not as well on the midterm. In this example, the correlation is 0.6. The closer to 1, or -1, the stronger the relationship, and the closer to 0, the weaker the relationship. Let's look at an example of a perfect positive relationship. This is a scatter plot of data with a correlation coefficient R of 1. As x increases, y increases for every single point. This makes a straight diagonal of points from bottom left to top right, indicating a positive trend. A correlation of 0.8 also has a very strong relationship, though it's not perfect. The points are a little bit more spread out, no longer in a perfectly straight line, but the positive trend is still very apparent. As we move from 1 down to 0, we can see each step the relationship gets a little weaker. 0.6, 0.4, we can still see a positive trend, but the points are spread out more and it's harder to see the trend. As we get really close to 0, the positive trend becomes difficult or impossible to detect. And then at 0, no trend is present at all. As we move from 0 to -1, from -0.2 to -0.4 to -0.6, we're starting to see a trend again, but this time it's in the opposite direction. We're noticing a negative trend where, as the x values increase, the y values decrease. As we get closer and closer to -1, the negative relationship becomes stronger and stronger. At -1, we have a perfect negative relationship. As x increases, y decreases for every single point. Let's look at how to calculate a correlation coefficient using the calculator. The owner of a ski apparel store has noticed that sales are higher when the temperature falls. He has collected the high temperature and daily sales for 5 days this year. We want to find the correlation coefficient R of this data. To do that, we'll enter the data into our calculator. But first, to be able to use the calculator to find correlation, we need to turn diagnostics on. To do that, we'll press the second key and then the 0 button to get to the catalog. We'll then press the inverse button, which will skip down to the D's. We'll then scroll down until we see diagnostic on. We'll then press enter and then enter one more time. Now that we've done that, we can enter the data into our calculator. To do that, we'll press the Stat button and then select Edit. We've already entered the temperatures 52, 41, 30, 26, and 25 into L1, and then the sales in hundreds of dollars, 15, 22, 18, 28, and 27 into L2. Before we find our correlation, let's look at the scatter plot for our set of data. To see the scatter plot, we'll press second, and then y equals for stat plot, and then we'll press enter to select plot 1. Our x list is in L1, and our y list is in L2, so all we need to do is turn it on. So we'll press enter to turn plot 1 on, and then we'll press graph. From the default view, we can't see our points, but if we press zoom and go down to zoom stat, and select that, we can see the scatter plot of our points. What we're noticing is it looks like there's probably a negative trend. But let's go ahead and find our correlation to find out for sure. To do that, we'll press Stat, and then right once to Calc, and then down to Linear Regression or LinReg. We'll press Enter. Our X list is in L1, and our Y list is in L2. So we'll just move down to Calculate and press Enter. If you have an older calculator, you'll need to type in L1 and L2 before pressing Enter. To do that, just press the second key and the number 1 for L1, and then a comma, and then second and L2 for L2. Here we see the A and B for the linear regression, and also R, negative 0.78, rounded to 2 decimal places. This tells us that the relationship between temperature and ski apparel sales is negative. As temperature decreases, sales increase. One of the things you'll notice is that the slope of the regression, A, is also negative. The slope of the regression line and the correlation both tell us about the direction of the relationship between our variables, so they'll always have the same sign. In this example, a negative correlation makes sense. People ski more in colder weather, so it makes sense that sales of ski apparel would be higher. However, we want to be careful, because a strong correlation between two variables does not mean that one variable causes the other. Correlation only tells us that the variables are related, it can't determine cause. A good example of this is the relationship between pollen count and swimwear sales. We can see from the scatter plot that as the pollen count increases, swimwear sales increase. But does an increase in swimwear sales cause an increase in pollen count? Definitely not. And does an increase in pollen count cause an increase in swimwear sales? Also no. What's really happening here is that pollen count increases in the spring and into the summer, which is also when people are more likely to go swimming and buy swimwear. So the correlation between pollen count and swimwear sales is not because one causes the other, but because both are caused by changes in the weather.